Okay, in this presentation we are going to look at Markov chains. So essentially what we have here is a no claims discount system has three levels of discount. Level 0, which means no discount. Level 1, which is a discount level of P, which might be, let's say, 15% off your premium. And level 2 is a discount level of 2 times P, which is twice as good as P. So, and you get that if you're on level 2. Here, P is between 0 and 0.5, obviously. Because if you have it as 2P, it cannot go exceed 0.5. Otherwise, they're giving you money, you know. So anyway, doesn't make that. We have to have that basically. Now, the probability of a policyholder not making a claim in each year is 0.9. So that is a probability that they do make a claim of 0.1. In the event of a claim, the policyholder moves to or remains at level 0. That's the whole idea of a no claims bonus. Otherwise, the policyholder moves to the next highest claim level or remains at level 2. The premium level at level 0 is £1,000. Okay, so derive an expression for P in terms of P for the average premium paid by a policyholder once the steady state has been reached. So first off, what we have to do is calculate the steady state and then work out the relative proportions. So first off, let's look at the transition matrix. So actually, the transition matrix, and I've started into the calculations there already. So there, if you make a claim, there's a 10% chance of that, and there is, you stay at level 0, 1, or 2. So if you make a claim at any level you're at, you go back to level 0. Okay. If you don't make a claim, you go up to level 1 in the next phase. So if you are in level 0 and you don't make a claim, next year you'll be in level 1, which means there's a 90% chance of that. And if you are in level 1 and you don't make a claim, that means you go up to level 2. But if you're in level 2 and you don't make a claim, you sort of stay in level 2. Okay? But if you do make a claim, there's a 0.1 chance you're in level 0 next time round. Okay? So that is the transition matrix, and what we're going to do here is calculate the steady state probabilities there. I just paused the video to write in the approach that we are going to use. So the steady state probabilities is denoted pi, and it's a column vector comprising pi 0, pi 1, and pi 2. And over here we have the transpose of that, which is essentially a row vector comprising the same numbers, the same components, pi 0, pi 1, and pi 2, but just arranged as a row vector. A corresponds to the transition matrix that I just described. So what we're going to do is solve for pi 0, pi 1, and pi 2. So what we'll do here is just sort of work through it as a matrix calculation. So what I will do here is just sort of pick this out and multiply it by the rows, by the columns of A, and this will give me each respective value of pi. Okay, so pi 0 times pi 0, pi 1, pi 2, matrix multiplication of 0.1, 0.1, 0.1, it will give us this expression here, and that will be equal to pi 0. Now just by definition, pi 0 plus pi 1 plus pi 2 is equal to 1. So therefore what we have here is 0.1 times 1, and that is equal to pi 0. So that is pi 0 is equal to 0.1. So let's look at the second column, which will give us pi 1. Okay, and what we have here is pi 0 times 0.9, and that is equal to pi 1. Okay, so looking through that, what we have there is just tidying that up. 0.9 times pi 0 equals pi 1. That means pi 1 is equal to 0.09. Okay, and finally solving for pi 2, 0.9 times pi 1 plus 0.9 times pi 2, that is equal to pi 2. So just sort of quick remark, it is the third column here on the transition matrix that we're using here, and that gives us a solution for pi 2. Okay, so pi 0 times 0 is 0. pi 1 times 0.9 plus pi 2 times 0.9 equals pi 2. So matrix multiplication. So that means 0.9 times pi 1 is equal to 0.1 times pi 2. So essentially subtract 0.9 times pi 2 from both sides. Just multiply both sides by 10. We get 9 times pi 1 is equal to pi 2. That means 9 times 0.09 is equal to pi 2. And that means that pi 2 is equal to 0.81. And that actually does give us, just to check that, and something you should always do, that adds up to 1. Okay. 0.10 plus 0.09 plus 0.81. And that is equal to 1. Great. So the average premium paid is essentially, I'm just sort of making up a notation for this, but this is what we're asked for, but just something like this, is the probability times the proportion of the premium paid, I suppose, by the proportion. So there's a 0.1 chance you remain at level 0, which means you pay 100% of the premium, or 1. There is a 0.09% chance that you are at level 1, which means your premium is 1 minus P. And then there's a 0.82 chance that your premium is, you're at level 2, which means your premium is 1 minus 2P. And that is, the premium level is 1000 because you start at 1000. So just working that out, what we end up with is 1 minus 0.9 times P minus 1.62P times 1000. So that is 1 minus 1.71 times P times 1000. That's just a little mistake there. That's just, it should say 1 just times 1000. Okay. So that is it. Yeah, that's it. That's a long run expression. Remember, P cannot exceed 0.5, so that cannot exceed, that cannot turn into a negative number, basically, because, you know, P is capped at 0.5. All right, we'll leave it there.